In the previous demo, we looked at calling a WCF data service from a WPF application. And we did use the WCF Data Services client library, and that was why we were able to write a link query. But we need to explore a little bit more what's in the client library, because there's more in there than just the ability to write a link query. Although what we've seen so far is very useful, there's actually more. There is more, and we'll take a look at it here. There are three main classes in the WCF Data Services client library that you'll work with: the Data Service Context class, the Data Service Query class, and the Data Service Collection class. The Data Service Context class represents the runtime context of the service. So after you add a service reference, this class contains a property for each entity. So we saw in the previous demo that we were able to say context.customers. Not only does this give you querying access to the entities, but it also tracks changes. So it keeps track of additions, subtractions, modifications, etc. Then requests to the service are represented using the Data Service Query class. This implements iQueryable, so that's why we were able to write a link query to talk to the service. And it returns an IEnumerable of the requested entity type. So when you make a call to the service, you're going to use an instance of this Data Service Query class. And as we'll see in the demo, it supports more than just writing link queries. The Data Service Collection class represents a collection of entity objects, and it inherits from an observable collection. So that means you can bind to it and enumerate through it, etc. It also implements iNotify property changed and iNotify collection changed, and therefore helps keep track of any updates or additions or deletions that you've done with your collections. And this class makes sure that the controls in your UI and the data stay synchronized, and that makes data binding easier. So we're going to see examples of all of these in the demos. Before we get to demo, let's drill down a little bit more on querying. All queries of a WCF data service are instances of this generic data query service class. And then all queries belong to a data service context. So whether you write a simple link query or you query in the other ways we'll look at, you're always essentially using this data query service class. You're also basing that on a context, which is essentially your conduit from your code to the service. And then the client library translates your queries into HTTP GET requests, receives the response back, and translates your response into instances of your entity classes, which is why in the previous demo we created a context and we specified the URL of the data service, but then after that we just wrote code. We wrote a link query that got translated into an HTTP GET, which was sent to the service, which sent back information, which is a big blob of XML, and then the data service library translated that XML into a collection of customer objects. So we don't have to do any of that work. Now, when do you actually call the service? If you're calling a WCF service, and then you call service.getCustomers, it's pretty clear that at that point in time you're calling the service. It's not as 100% clear always exactly when you're calling the WCF data service. There are four primary ways that you can call the WCF data service to get data. One, you enumerate a data service context property. In other words, you do something like loop through customers. So then as you're looping through customers, when you start reading the first customer, at that point you've sent a query to the service that says bring me back customers. Or you define a link query and assign the results to a list collection, or you call first or single. So you can create an instance of a link query, but you haven't actually called the service until you use the results. Or you can call the execute or begin execute method of either the data service context or the data service query class. And there's an execute and a begin execute because you can use the execute for synchronous querying or the begin execute for asynchronous querying. So if you query synchronously, then your UI is frozen until the query comes back. If you need the UI to not be frozen, you could do asynchronous querying by calling begin execute, and then you would just handle the event that occurs when the service comes back. So depending on how long it takes to call the service, you may find benefits to doing asynchronous querying. And then there's a fourth way of querying. You can call the load method of the data service collection class. And then we're going to see 5 examples of querying a WCF data service. And these are going to be essentially my 5 stock demos for talking to data. Bind to a list of customers, bind to one customer, display related data, data entry, and use a collection view source so you can do navigating and filtering and sorting and all that fun stuff. Let's go see more about how to use the WCF Data Services client library to work with WCF Data Services. I have the WCF Data Services demo sample application up and running, and we're going to look at various examples of working with data using WCF Data Services. Now the first thing I want to do is look at the various ways there are to query a data service. So I have in here a window with 5 different examples of querying. And let me bring up the code because we're going to have to reference it as we go along. That's in Query Data Service. Okay, so the first thing we do when the window loads is we create a new instance of the Northwind Entities class. And this is our data service context. And this is our conduit into the data service. It is what translates whatever code we write into something the data service will understand and then handles the results that come back. And it also does change tracking for us. So let's run some queries. Let's also get this a little bit smaller so it takes up a little less space. There we go. Okay, in the first example, we are going to call the service, bring back a list of customers, and display them in the list box. And then when I click a customer, I display additional information. So here's the code that ran. The first thing that I did was I created a new generic list of instances of the customer class, and then I enumerated through the customers property of the data service context for each as customer in customers. And then for each of those, I added the customer to the generic list of customers, and then I bound the list box to that. So at the point I got to this code here, I started looping through the customers. I actually then went off and called the query. And notice that customers is a collection of the data service query class. So each entity is essentially a query because, again, each collection of entities is a query to the service. Okay, so back to the code. When I say context.customers, it's essentially the same as saying this. And then I'm looping through each customer, so at the point I start looping through these, when I get right here and read the first customer, then my client code has gone off and talked to the service and said, bring back the customers. The service brings back all of this information, which the data service client library is able to convert into instances of the customer class for me, and then add those to the customers list and display them in the list box. In the second example, I clear out the list box and I run a link query. And this is what we did in the previous demo. I create a query from cust in context.customers, select cust, and then when I convert that IEnumerable to a list, that's when my code goes off and calls the WCF data service and asks it to send back customers. And now I have a list of customers and I can bind the item source property of the list box to that. Okay, let's look at a couple more examples. I'm going to create a new list of customer, and then what I'm going to do is I'm going to call the execute method of the context. And this context, which is, if we come back up here, a new Northwind entities. Let's look at the definition of that. Northwind entities inherits from data service context. So this Northwind entities is my specific data service context talking to the WCF service. Okay, let's close that. Let's come back in here. All right, so I specify a URI, localhost 8095, WCF Data Service, / customers. So that is this exactly what's entered in here, except that the sample runs on 8095. There we go. What I did was I hard-coded this to use port 8095. I didn't want it to randomly select a port, so I asked it to use 8095. Okay, we're on example number 3. So now what I'm going to do is call the execute method of the data service context. Execute is a generic method, so I need to specify what my entity is, and then I pass a URI. And I pass the exact same URI that I would go type into the browser. Northwind WCF Data Service.svc / customers. And what comes back, what comes back is an IEnumerable. And so I can then enumerate through that. So for each customer in whatever the data service sent back, add that to the list of customers, and then bind the list box to that. And once again, the list box displays customers, and each of these is an instance of the customer class, so it's easy to go read the company name, city, and country. In my 4th example, I'm going to create this customers object, which is an instance of the data service query class, and I specify the entity, customer. And then I set this equal to context.customers, and then I call the execute method of the data service query. And that again, example number 4, goes out to the WCF Data Service, brings back all of the customers, and I bind the list box to that. So this execute method returns an IEnumerable. And then in my final example, I'm going to use the data service collection class. The data service collection class was designed to make data binding easier. And so when I call this code, I'm going to use a link query. So from in customers, bring back all the customers. Then I'm going to create a new instance of the data service collection class, which is generic, so I have to identify the entity. And then I pass to that the query. Then I call the load method of the data service collection class, asking it to load a collection of entity objects. Where do the entity objects come from? They come from the query. And so when I call the load, at that point, I go off and talk to the WCF Data Service, which brings back the results of this customer query, and I load that into the data service collection, which is now populated with a collection of customers. Then I bind the item source of the list box to that. So 5 different ways of doing the exact same thing, right? Well, it's 5 different ways of querying. I can enumerate through the customers. Maybe I just want to write simple code in a for each loop, go through each customer and do something. In order to do that, I need to send off a query, which is one of the reasons why customers is an instance of data service query. So I can loop through them, or I can write a link query. I mean, we're going to often want a query, so that's good. There may be times when you know what you need to type in the browser, but you don't know how to translate that into a link query. WCF Data Services have a particular language. So for example, the things you type in here, this filter equals substring of, you may read an article somewhere or see a blog post where the person gives you this, and you don't necessarily know how to translate that into link code, into a link query, so you could directly pass that to the service. So this example, although being a bit of a special case, could really save your bacon at some points. We know that customers are instances of data service queries, so we can execute directly off that. And then, as we'll see in a later example, the data service collection makes data binding easier. So, yes, these are 5 different techniques, but consider them 5 different tools you can use to query data sources. Alright, so now we've seen some examples of querying. Let's now look at what has become my standard collection of data demos. Retrieve a list of customers, retrieve one customer at a time, retrieve related data, data entry, and I have 2 examples of that here, and then use a view. So let's retrieve a list of customers. I bring back all of the customers, and I display the name, the city, and the country. And then when I select a customer, I show information for that customer and the number of orders they've placed. And that is in the Retrieve Customers file, so let's look at the code. When the window loads, I create a new instance of the data service context, Northwind Entities, and then I query the data service. In the previous window, we brought back all of the customer information. So in every one of these examples, we brought back all of the customer data. But then the only thing we showed in the list box was the company name, the city, and the country. And so here I'm being a little bit more efficient than that. I don't want to bring down a whole bunch of information that I never look at. There are 91 customers, and I don't know that the users are going to necessarily look through all of them. Maybe the users just want to peruse and say, oh yeah, these guys, what's their phone number? Or, oh yeah, these guys, what's their fax? How many orders have they placed? How many orders have these guys placed? So all I want to do is bring down the information that's displayed in the list box, and then when you select a customer, I want to go back to the service and retrieve the information for that customer and the number of orders. So my query here says, from customer, select new, customer ID, company name, city, country, and then convert the iQueryable to a list and put it in the item source. And if you saw that tooltip, you got a taste of what's coming up next. Now, when I select a customer here, in the previous example, the list box contained instances of the customer class. So I could just go get the selected item, cast it to customer, and be good to go. But I don't have instances of the customer class here because I've created a new class that only has 4 properties. It's not a customer class. It is an anonymous class. So I cannot at design time read the customer ID property from an anonymous type. So what I'm going to do here is use reflection. So I'm going to say get me the selected item and then get its type, which here is item type and it's actually anonymous. Then I'm going to call the getProperty method and get the property called customer ID. And I know there is one, so that works. And then I'm going to call getValue on that to get the value of that property, and that's what goes into customer ID. And then I'm going to run this query. From customers, get me the customer that has that customer ID, and because it only returns 1, I call single. And at this point here, when I call single, then I run the query. And basically, the query I'm sending up is this one here. Let's say I typed in alf key. That's the query that gets sent back at this point here. And then I bind the customer grid data context to that. And then I make another query, another call to the WCF Data Service to get the number of orders for that customer. And in both of these cases, I'm just using link queries. So this is pretty efficient code, even though it was a little more work for me, because I'm only bringing down the information that I need. There's no wasted information. And then when I select a customer, I go back and bring down the information I need. So yes, there are more calls across the wire, but I'm not making calls and bringing down information that I don't use. What if I want to see one customer at a time? So I can enter alf key, click find, and bring down the information for this customer and the number of orders. And that code is in the retrieve customer example. And this is essentially the same code in the previous example. So this is pretty much the code that was in the list boxes selection changed event handler. Only now I set customer ID equal to whatever the user entered, and I converted it to upper because I assumed, well, the customer ID is in uppercase and this is XML, so if I pass alf key in lowercase, the data service isn't going to know what to do with it. But then I discovered that that is an erroneous assumption. I can pass alf key in lowercase and the data service knows what to do. So I don't literally need this to upper here. So bring back the customer, bind the grid to it, bring back the orders, and display them. Okay. Next example, we want to see related data. In the top list box, I show categories. When I select a category, I show the products in that category. When I select a product, I display additional information on it. So in my code, when the window loads, create a new instance of the data service context, write a query to bring back category information, and then bind the list to it. Notice here that I'm bringing back all of the information in the categories entity. So you might be thinking, well, wait a minute. Isn't that inefficient? Categories, if I recall correctly, the categories table in Northwind has a category ID, category name and description, and a picture. But you're not displaying the picture, so why are you retrieving it? And the picture is a fair amount of information in all likelihood. Well, wait a minute, the service doesn't return picture. That's because I told it not to. So I guess I had two choices. I could either return category ID, category name, and description, and then use reflection to get the category ID. But then I said, you know what? I don't even use the picture, so why have it? So I deleted it. I just came in here after creating my entity model. I just came in here and I deleted the picture. So it's not even part of the model. So that's how I dealt with that issue. So now I can just retrieve category classes, and then when I select a category, I want to load the products in that category. Let's go back to the entity model for a second. Categories have a property called products, and that products property has all of the products for that category. So in other words, if I go back to the code here, for this particular category, I can say category dot, and there's a products property which is a data service collection of products. Now we're using the entity framework, and the entity framework by default says, I'm going to be smart about this. Just because you ask for categories, don't expect me to automatically send down all of the products as well. The Entity Framework uses deferred loading. Now you can ask for loading up front, but the default is that you don't get that information until you need it. Well, at this point in the code, I actually do need it, because when I click on a category, I need to see the products for it. Now I could write a query to go get the products for each category, but I can do it a little bit easier because all I need to do is call load property. And load property is a method of the data service context. It takes two arguments: the entity object and the property. So this says, for the category that the user selected in the list box, go fill out the products property. And that basically is doing this. For the category the user selected, go get me the products. So that's what happens right here. Now, products have a supplier. I don't want the supplier ID. One, that doesn't mean anything to me. I want the actual supplier. So for each prod in products, I can say prod dot supplier dot company name. So the supplier property of the product goes back into the supplier table, and then I can read the company name. And that's what I want to display in the list box. So for each product belonging to that category, I call load property, passing the particular product that we're on in our enumeration. Go get me the supplier property, so that in the list box I can say, show me the company name right there. Start this up again. And then each product is an instance of the product class, so it's very easy to then bind the grid below this list box to that product and see the information on the product. I've got two examples of data entry. So in our typical data entry form here, we can enter a customer, we can make changes, we can add a new customer, and add that. Then we could later on get that customer back and delete it. Okay, so typical data entry stuff. When the window loads, we get a new instance of the data service context. We're also doing that when we find. And it's not a bad idea to refresh your context on a fairly regular basis. That way you 100% guarantee that you are always going back to the service and getting the latest version of the data. So I'm going to do that here when I find, bring down the customer, and then if I make changes, if I want to save those changes, I call the update object method of the data service context, and I pass the object, the customer object, that I'm currently editing. And that is what this query returns, so customer is the customer I'm looking at. So I call update object if I'm currently editing an existing customer, and then that saves the changes locally to save the changes back to the service so that the service will write them back to the database. I call the save changes method of the data service context. This returns a data service response, so I could work with that, but in this code I'm just saying if it doesn't blow up, then it worked. So in my try, I call save changes, and the customer information was saved. If it wasn't, then it wasn't saved, then I'll show why. Now if I'm in the process of adding, then I'm going to call the add to customers method of the data service context and pass the new customer, and then save those changes. The new customer is created when I click the add button. And here I call the create customer method of the customer class, and I pass TBD and TBD. Why do I do that? Well, customer ID and company name are required. They are marked as required because SQL Server requires them. So in the entity model, they're marked as required. And then when I add a service reference to the WCF Data Service and Visual Studio generates the code for me, it creates this create customer method and automatically includes the required fields. So I create customer with an ID and a name of TBD, then set the context of the grid to that new customer, and then when I click save, I add that customer to the collection of customers belonging to the data service context, all local, and then call save changes to send those changes to the WCF Data Service. And then when I delete, I call the delete object method of the context, and I delete that particular customer object and then save the changes back. And then if I call undo, I just clean out the grid. So that's one way of doing data entry. The other way, and it's the exact same form, so I don't need to necessarily go through it, but the code's different. And here, I'm going to use the Data Service Collection class. The Data Service Collection class inherits from observable collection and implements iNotify property changed and iNotify collection changed, and it keeps your user interface controls and your data in sync. So here's what I'm going to do. When I retrieve a customer, I'm going to call the same query, but now I'm going to create a data service collection. In the previous example, I just set the data context of the grid to the customer that came back. But here, I'm still going to do that, but in between, I'm going to create a new instance of data service collection, which is a generic class. So I have to specify the entity. And then I'm saying this data service collection is going to come from this customer query. And then when I load this, when I call the load method, that's going to go out and execute the query. The results will come back, and I populate my data service collection with one or more customers. In this case, it's one customer, but it could be multiple customers. The benefit of the data service collection class is that it keeps the controls and the data in sync. So now when I save, I don't have to call this context update object method because the context's already been updated. So I don't need this line of code here. This has already happened. I can just call save changes. And if I add a new customer, I don't need this line of code here. The changes have already happened. Actually, I need an entirely different set of code, and I'll show you why in a second. If I click delete, I don't really save much there. In the previous example, when I deleted, I called the delete object method of the context and then save changes here. I still have to remove the customer from the data service collection and then call save changes. But certainly for the update and in a lot of normal cases for the add, I don't have to save changes. Now when I click add, this code's different. I create a new instance of the customer class, set customer ID and company name to TBD, and then I create a new data service collection and I add the customer to that collection. Now you might be thinking to yourself, what? Wait a minute. Didn't you create a data service collection here? Don't you already have customer collection? Why can't you just add this to customer collection here? Well, let's try that. Let's stop this. Let's comment out this code. Just add it to the existing customer collection. Well, let's see. Let's run this. And let's try this scenario. I bring down a customer. I click add. I fill out the rest of the information. I click save. Worked like a champ. Let's prove that. TBD, there it is. Works great. Why all these extra steps? Let me show you why. Here's another scenario. I don't want to look at an existing customer. The first thing I want to do is add a customer. Uh-oh. Object reference not set to an object. What object reference? Customer exists. Customer collection is null. Customer collection is null because I haven't created it yet. I create the customer collection and find. Oh, all right. I will then create a new customer collection because it really only contains one customer, so no big deal. New data service collection customer. Oh, there it is. It's already filled out for me. All right, happy now? Perfect. Now let's run this. All right, so now I come in here. The first thing I want to do is add a customer. An item could not be added to the collection. When items in a data service collection are tracked by the data service context, new items cannot be added before items have been loaded into the collection. What's the problem? The problem is that the data service collection has to belong to a context. And this data service collection that I created out of thin air is not attached to any context. So yeah, you got a data service collection, but what service is it working with? Where's the data coming from? I don't know. So how am I supposed to add a customer to this and track it? How am I supposed to add an instance of the customer class from Northwind WCF Data Service if I can't track it? And the problem is, I can't just create a data service collection out of thin air and expect that the context, which is this, is going to know anything about it. I didn't have that problem up here because I specified my context. I said this query comes from this context. So this query in here is already connected to the context. So when I load the collection, this collection belongs to this context. But if I just go and create one from scratch down here, it's not hooked up to any context. So that's why I wrote this code. Create a new data service context, specifying the entity, and hook it up to my existing context. Then I can add a customer and set the data context to customer. And again, the reason I'm doing this is for the scenario where I come in and the first thing I do is add a customer. And now this new customer I've added is being tracked by the context. Okay. One last example in this demo. Let's use a collection view source. So I have a list of categories. When I select a category, rather than displaying the products in a list box, I want to display them one at a time, and then I want to be able to navigate through them: first, previous, last, first, sort by name, sort by supplier, and filter out only the products that are low in stock, or clear the filter. And this is all in Use Collection View Source. So when the window loads, go get the categories. When I select a category, go fill out the products property for that, and then for each product, fill out the supplier. So that's here. We're at this point. So when we select a category, then I do that. But then I also want to get the view associated with the products. And in my XAML, if we go and look at the Use Collection View Source XAML, we have this collection view source defined. And if I do drag and drop data binding, Visual Studio will create collection view sources for me, but I can also create them in XAML. It's called Products View Source, and its source is products. And so in my code, I need to get a reference to that so that in code I can set the source property to the products that come back, which is a data service collection, by the way. Then, now that I have this collection view source, I can get the view, which is an iCollection view, and once I have the view, I can navigate. I can move current to first, move current to previous, move current to next, or move current to last, so I can scroll back and forth. I can also sort, and I'm going to go through this a little bit quickly, A, because this has now been a very long demo, and B, because I'm going to assume you've seen this code before. If I want to sort by name, I just clear out the collection of sort descriptions in the view and then add a new sort description specifying the property that I want to sort on, which is product name, and the order, which is ascending. If I want to sort by supplier, I clear out the sort descriptions, add a new sort description on supplier.company name, and then within company name, sort by product name. If I want to filter, I set the filter property of the view to this delegate, and the delegate takes each product as an object, casts it to product, and then looks at units in stock. If units in stock is less than 10, then the product is included in the view. So if I click low stock, the only thing that's in the view are the products in this category that have in stock less than 10, both of them. The data is still there. If I clear the filter, then I see all of the products. And to clear the filter, I just set it to null. So what you've seen in this demo is our standard set of data scenarios: bind to a list of customers, to a single customer, one-to-many, data entry, collection view source. And you've seen that a lot of the code we write is exactly the same. So the code we write in the UI is the same, but what we've seen differently is the code we use to talk to the WCF Data Service. And we're using the WCF Data Services client library to hide as much of the actual talking to the service as we can. We're writing fairly familiar code. We had to learn a few new classes. The techniques we use are pretty similar, and we're working with data coming from the WCF Data Service.